Hi, everybody. I don't know if, yes, I have an answer. The chat is working for the first time in the day. If you have, well, sometimes thanks, Christophe. So let's go for this presentation on Azure Sphere deployment. I guess this is enough for my face today. And let's go to the slides. Share screen. And let me share the screen. Okay. Excellent. Here we go. So this is a short presentation, half an hour, trying to go through Sphere, why Sphere, how Sphere, and where. Let me introduce myself, Thierry Joubert. So I'm CTO and one of the co-founders of Thierry about 20 years ago. I teach and I train engineers, students on different matters, mainly focused on embedded and embedded systems and application development using system services, object-oriented systems like micro EJ, and even graphic layers like Qt. I co-authored a book on Windows Embedded Compact 7 a few years ago, published at Wiley's in the US. This, well, Windows Embedded Compact was a former technology for embedded system provided by Microsoft, still available. And I'm also a software project contributor, architecture, even writing code or testing anyway. So I still have the hands in its agenda. Well, basically, we will go through why and how Sphere is there, example of solution, and then I'll try to introduce you to the device lifecycle and application lifecycle, so the practice of Sphere for a developer. Well, usually people start with lots of examples of casino being hacked or hospitals being hacked. Well, I'll share with you an experience we made. In 2008, we moved to our new offices in Paris and installed our own switching, telephone switching, box, PABX in a closet. Then a few years later, we switched to voice over IP. Everything changed, the phones, everything connected through RJ45. Great, interesting, more functions, and we completely forgot the PBX in the closet. Okay, and then this one came back to us a few years later. We had to pay the bill because the machine was hacked. In fact, the telephone, the standard telephone number was still connected to that PBX, and hackers did try and find the pin code to get administrator rights on that machine. And as soon as you get the rights on the machine, you're able to transfer the number to any number on the planet. So they were selling our phone number to call numbers in other continents. So this was not a catastrophe, but quite puzzling, especially for people giving advice to other companies about security. The good news is that this machine was not connected to the infrastructure, so no doubt about did we get something through that channel. Orange, our operator, was aware of the problem, and in fact, they called us after sending the bill. I mean, it's who's surprised there. The bad news to learn from: a powered computer in a closet is not a dead computer. Terrible. Okay. How many of these machines were just forgotten just because they've been installed there one day, and even the guy who did that job forgot about it. Now you forget, they don't. Professionals make a living on it. I mean, so it's this job. Obviously, they seek and they try all the time, so you can't escape. You can't escape the hackers. And that machine was designed in the 80s, and security was not a major concern, meaning that cat-digit PIN code as a password is well, okay, lowest thing possible. No expiration delay on that PIN code, no attempts limitation, so they could try till they find it. So this should not happen again. And now, what's the big issue with security, cyber security? Well, a computer, when you go to the basics, is an arithmetic automaton, crunch numbers, okay? And as mathematicians showed in the 19th century, anything can be moved to the numbers world, okay? This is something we do all day long nowadays. So basically, an arithmetic automaton can do anything. Great, we love it for that. Well, it's programmable. It's an automaton. It's a programmable automaton. So we can even change what it's doing. It can do anything, but it also can do anything else. That's fine. We also love it. Car makers, many industrial, they love putting computers in their machines because they can upgrade over the air, or they can upgrade of the field. They can modify the system without changing any mechanical pieces. Okay, and the cherry on the cake, it's auto programmable. I mean, program is data, as you know. There is no difference between the two in memory. So it can do anything else anytime. And now is the question, you buy a computer, you power it on, in the minute that follows, can you be sure that this thing is doing what you paid for? Well, even today, I can't, myself, I can't assure that my PC is doing exactly what I want it to do. I mean, I could have some deep root virus hidden there. Who knows? So the hardware is the problem. The virus is in the very nature of the machine itself. It will never go out. That's one thing. Security, usually in software, in computers, we solve problems with libraries, okay? Function collections, code. Can we solve the security with code? Can security be yet another library? People think that I need a cryptographic API and then I'm safe. Well, no, that doesn't work this way, because the average developer will use the API, follow the API, get last error, go to one, follow the API, get last error. This is the way you use a library, okay? Then the hackers don't behave this way. Hackers will, you provide a library, great, your code is bigger. My field of investigation is even bigger, and you introduced new opportunities. Every time you add a line, every time you add a kilobyte in your program, you provide space for them, okay? Hackers use existing software as bare metal to modify the behavior of the software. And bloated software nowadays makes their job even easier. So you can't solve at that level. We could also say that security is not a function by itself. You can't put it in the requirements of the system just like any other function. And also very important, hiding is not security. Little secrets. Okay, you can't guess my password. The key is under the carpet. Everybody puts the key under the carpet, not even thinking that people would guess that the key is under the carpet. Any trick a human brain can produce may be found by another human brain. That's so obvious maybe a giraffe or a rhino won't find, but who cares? They don't use computers anyway. So, and we come to a point also where major risks are taken by uninformed people. Most people don't know the consequences, don't understand how it works deep inside. Very few people understand how it works deep inside anyway. So security, well, security is a matter we know for long, okay? Security is trust, resilience, flexibility, evolution. Um, I think any good training on security should start with a physical visit of fortresses. We have a lot in Europe, and you can learn a lot from these. Basically, first thing is, what is the threat? The fortress has to be designed against the threat. You don't spend more money than necessary. I mean, it's the economical problem about it. Quantity of money you can put in security is limited. So it's a way of saying I must accept some risk or the risk. So fortresses have evolved through history to answer the threat. And you can see that all these different fortresses that about 2,000 years of uh, distance, they still have, um, layers slow down the threat, then then another wall after the wall, resilience, okay? And they have a core, trust. There is always a core place where you're safe. And then around that core place of trust, you built up walls that are protected by other walls. And you have to be able to communicate between these different places, flexibility. And if you take it on a long term, we could imagine that these three photographs would have been taken at the same place. Okay, fortresses have always been built on other fortresses, reusing some elements of the old one. And anyway, when the threat evolves, the fortress has to evolve. So these four elements are essential to security in the cyberspace too. From these conclusions, Microsoft has written a white paper about the 7 properties of highly secure device. Basically, they just take what I just said. Okay, how can you be sure your computer is doing what you expect to do? Well, you have to be sure that nothing can happen between the first millisecond of power and now. This is root of trust. It depends on the hardware. Defense in depth. How if even if the system is attacked, how can I survive an attack? Okay. Small trusted computing base. Well, I need a core that is absolutely safe and unbreakable. Compartments in order to be able to define rights and who can go where. No passwords, certificates everywhere for sure. Error reporting. The system shouldn't be silent. I should be aware of what's getting in. If there are mistakes, if there are tries of changing rights and things, I should be aware. And moreover, that the whole thing should be uh, renewable, updatable at any time, just because the threat changes. Okay, and so only flexible system or can survive. The idea of a system that is built once and never updated is something that we use a lot in embedded systems because of certification, for example. But then you shouldn't connect that, or you shouldn't allow somebody to get access to this system. And we'll see Sphere might be a solution for such problems when you need to connect something that absolutely cannot be connected. So Sphere is an end-to-end solution. It's hardware chip, it's operating system and environment, development environments, runtime and development environments built up, and a security service in the cloud all these three things together built up the end-to-end solution. So let's go from the hardware to the cloud. Azure Sphere SOC is a hardware solution that contains a Microsoft IP. It's an open source IP called Pluton. This solution comes from the Xbox security element of their historical console, and this comes with connectivity. Well, space for an ARM Cortex, or well, a CPU that is able to run. We will see a Linux system and an potential extra microcontrollers, Cortex M, 1, 2, 3, 4, depending on it's a SOC, so it depends on hardware makers' decisions. Plus, well, access to external world, and we're not talking about PC here. We're talking about an embedded device, an MCU. So it's GPIO, it's I2C, it's SPI, UART. Well, okay, no VGA, no HDMI. Okay, for sure, no screen. So we already have off-the-shelf hardware. MediaTek has been working closely with Microsoft to produce the first Sphere SOC. Other chip makers, including NXP, including Intel, are working on it. We already have development board. We have modules. Avnet has produced a module that you can integrate in boards. So there are several solutions on the hardware side, and it's growing. On the software stack, the central element is the LHOS kernel. It's a custom Linux kernel. The source is available on the link here. I just I played the game, and in fact I downloaded the kernel. I downloaded that kernel. It comes 600 megabytes in the tar. So I have an excellent, my favorite Linux, which is the WSL2 kernel installed on my Windows. So I use that WSL to copy the source, and then I did the def config, and then install JCC and make cross compile XIP image, and I got it. I mean, the whole thing built for a few minutes. Okay, everything came up nicely. Okay, and at the end, if I just look here, LSL, I like to show Linux kernel built in a Microsoft oriented presentation, because it shows that nowadays Microsoft is really devoted to Linux and open source. So if you see the README, where am I? SRC, yes. I started the build. It took 20 minutes. Okay, it took 20 minutes, and if I take a look, it's XIP image. It's been built here. Okay, ls-l XIP image, 2.4 megabytes. Yes, Microsoft squeezed down the kernel Linux down to less than 4 megabytes at the runtime, because the SOC is 4 megabytes anyway, so you can't use all the SOC with the kernel. So this thing here, there are interesting presentations on the web from that team explaining how they did to squeeze Linux to this thing, and especially with the security. If you take a look at the code, at the source code, we have Unix SRC. If I go to the include, for example, it's interesting. There is Azure Sphere folder, and the Azure Sphere folder contains Pluton Remote API, Security Monitor, and Security.h. Obviously, when you know the architecture of a Sphere SOC, that makes sense. Okay, so let's go back to this architecture. So this OS is the central unit where you will download your apps and run your apps. The general Sphere runtime architecture to the right here shows your customer app running on the POSIX runtime, laying on the networking management and application management of the OS. And then you can also have customer apps, Cortex M apps, we'll speak about real time, that lays on dedicated Cortex M microcontroller things. And the Pluton security system, which is this core dedicated so hardware in the SOC. Solution scenario. Well, two types of implementation. Greenfield, new device and equipment, where you will choose your, maybe design your board, use a chip or a module, or brownfield, existing device and equipment. This is one of the first targets we have, brownfield, where people have equipments and they need to connect them securely somehow. So in that case, we have what we call the Gordon devices for brownfield. So built on Sphere hardware. Some manufacturers have provided these black boxes with very small connectivity and all the utilities that are required for a Sphere device. And that Sphere device will act as the barrier between the cloud or whatever connectivity and the brownfield device. So no specific communication between Azure Sphere and the specific device. UART, USB FTDI, or even GPIO. Okay, and Azure Sphere service will provide all app OS update, online failure reporting. So this is a typical architecture for a Sphere app nowadays. Now provisioning. Well, if this is the view of my desktop right now. So I have this board, which is the first dev board provided for Azure, and I will talk to that. Well, I will try to explain the elements that built up the chain of using such a device securely. Okay, and it has constraints. So the first thing is that a chip manufacturer will embed secret keys in the chips and share these secret keys with Microsoft to be stored in the Azure Sphere security service. That makes sense, but quite standard as a way of handling security on chips. Next is an OEM will build up boards with these chips, and people will buy these boards or have access to these boards as company employees. In order to be able to use such a board, you don't just plug it. You have to first connect to an Active Directory, either your own Active Directory or Azure Active Directory as a user. You need a user account in an Active Directory. And from that user account, you will create or join something that is called a tenant in Azure Sphere. Okay. A tenant is the identity of the logical part of the Sphere solution. There is the hardware to the left and the logical and world to the right. So each target will be unlocked, claimed, if you want, will be claimed by one and only one tenant. And this is a one-way process, no return on this. So as soon as you, for example, clean up a tenant in Azure Sphere system, automatically the device will die. This is one way of being sure for a company that you don't have, ghost devices running around when you stop something, for example. But it's a constraint. There is a lot of concern about that. Well, as soon as somebody has access to a tenant, that somebody will be able to talk to that board and deploy software on it. and this is it. To do this, we have a PowerShell control interface. Okay, so it's provided with PowerShell. I just open my PowerShell and Azure Sphere. Azure Sphere is the command that will allow me to manipulate my device. I will use the interactive interface. Interactive, because I don't know all commands by heart. Azure Sphere Interactive, okay. So if I say device and list attached, I'll see if I have a device attached. Yes, I have a device attached, okay. Device Wi-Fi, is that device, oops, sorry, device network. I think I have a Wi-Fi. I need to precise what I want about Wi-Fi. Sorry. List. And I see that I have two Wi-Fi available. Okay, so I'll enable one of the Wi-Fi that I declared in the board. All that stuff was done with this Azure Sphere tool. Okay, enable ID 1. This is my phone Wi-Fi. So the board should be connected now. So this is the typical interface tool that is used to make the link between your device and the Azure Sphere. Actually, my machine is connected to Azure Sphere automatically through this tool inside PowerShell, and does the job of querying Azure Sphere service to do all the job required and get I could say tenant, for example, to see tenant show selected. Show selected. Is there a tenant here? Yes. Theosphere. Well, Theory for Sphere has been created, and this is where my board is hosted as a tenant right now. Okay, so you see that I can talk to my board through this tool securely through the. So all the administration is done through that local tool on your PC. Depends on the Azure Sphere SDK. You have to install the Azure Sphere SDK to get this. Now, so the fact that you have a tenant is linked to the fact that you have a you will have certificates. Okay, so you will manage tenants. A tenant may have administrators, contributors, reader. So you manage rights, access rights, and you can only access a board if you belong to the tenant of that board. Now, application deployment is made through the service of the Azure Sphere service. So the binary will be pushed. The binary will be pushed to the tenant space in the Azure deployments, and then it will go down to your update your Sphere equipment. And moreover, it will even update the OS if the application update requires an OS update. SDK and tools, well, the best is to show you this tool, Azure Sphere. I loaded, it's a CMake list project. Now Visual Studio is able to work with CMake. So I have a CMake list. So this is an app where I can just put a breakpoint here. Let me just go to the main and break if I can break there. Okay. And let's start the GDB debugger on my board. Okay, remember it has a temperature sensor. So now it's copying application on the device, and you'll see pretty interesting that in the process of sending the runtime to the device, you'll see .so go through shared object files, no DLLs. So see custom SO, runtime SO, Wolf SSL SO. So we are in a ELF. We are in the world of Linux. Okay. So now I break. You can see that the memory used is displayed on visual, and I can just say go further. Okay. So now my device will connect to the Wi-Fi, and it's flashing right now. It's running. So it's querying the temperature information and sending it to my Azure portal. It's If I take a look at the app manifest, you see that the allowed connection is Thierry's Azure device.net. So I send data to that Azure device.net and got authentication from the Azure Sphere tool. So if I move to my Microsoft IoT, Thierry's IoT, I'm on the Azure portal right now. I should see, I need to refresh, but I should see that some activity now is coming up. In a minute, I'll see that the statistics on the packet coming in should grow up. Takes a minute or two. Okay, so this is how I can develop and test apps. And as soon as my app is ready, I'll just package that app and send it. Let's stop the thing right now. Okay, so you've seen the tools and the projects, the manifest, which is very important because the manifest contains all the information about security at the application level, which GPIOs are allowed or not. This is typically a place where if you try to access a forbidden GPIO, some alert will be sent up towards to the Azure Security Service. So let's now speak about real-time apps, and I won't be too late. So real-time cannot be achieved by Linux system. Okay, you can't achieve the microsecond. You can't bing bang a GPIO to control some device on I2C, for example. You can't do that with Linux. It's not made for that. So if you really need to access IOs on the real-time level, you need to develop either bare metal or with an RTOS on the M4. Okay, so all capabilities should be allowed at the manifest level, and inside the Azure Sphere SOC are built-in mailboxes to communicate between the IPC, if you want. There is no traditional IPC available inside the local port of the Linux kernel for Sphere. Okay, it's been squeezed down, so you can't write file. You don't have a file system, so they built mailboxes to allow for IPC between the different application present. And in fact, an M4, a Cortex M4 app will come up to the Linux environments and be allocated to the memory, and the Linux environment controls the memory, and the Linux environment will be responsible for installing and launching that M4 real-time app on the SOC. So they have dedicated IO blocks, ADC channels, well, things that have been prepared to answer some of the problems. You've noted that most of the interface are buses, I2C, SPI, UART. The app requirement should be prepared for that, and the linker prepared to set up the memory, the mapping of your code direct to the place where it will be loaded inside the core memory, accessible to the M4. The model for memory is a virtual memory model at the Linux level. So you may even run several Linux apps. Just these apps have to be set up as authorized apps running on the Sphere device, and they will all have their own environment. Well, beware that the overall memory available is 4 megabytes. So you won't write something like Nginx or anything else. That was it. So I could go through my slides, and was lucky enough that my demos worked. I hope you got some information about it. Let's move to the. It seems the chat is working. Let me go to the chat. Maybe I can unshare the screen. We're back on the video. So, is the chat working? Works. Ah, Pierre. See, Pierre, I'm building a Linux kernel in the middle of a Windows. Well, not Windows, but Microsoft technology presentation. So that's what else. So, do you have questions? I know I'm not quite on time. Malediction. WSL, Windows System for Linux, works quite well. I must admit. We used it recently to build an Android image. Worked perfectly. No questions? So either you got it or got nothing of it. The slides will be available at some point, and also, just like last time, the presentation videos will be posted to YouTube. So how does it cost? The price is on volumes for sure. There is no price for the technology itself. As you saw, it's open source, so it's the business model for Microsoft is to have as much devices, Sphere devices, as possible. The price is quite low, and it's something that relates to the numbers. I don't even have the real figures for that, because as usual, it always depends on the local situation of the client, of the customer. But it's compared to other technologies available on the cloud. It's quite affordable. For sure that you must compare how much would you spend to develop such a thing. And it's a hell to develop secure software, because you just not develop it, but you have to push it to certification. And pushing software certification is very, very expensive. And cost a lot of time. Thanks, David, for the question. Yeah, one project, Microsoft, it's a company in Seattle, a small company. They sell hot water for quite a high price. I think it's called Starbucks, something like that. It's a green, green flag. Yes, Starbucks was the first company to use Sphere, in fact, to protect their secret recipes. They previously used USB keys, and people would go through old shops and put the new recipes every year using a USB key, and now they use Sphere as a device to push that information securely. So it's the flagship for Sphere. We heard about it still the very beginning, Now other people are getting in. And interesting to see that hardware makers like NXP and even Intel are integrating the Sphere technologies themselves, showing that there is some interest in that domain. Thanks, Jean-Gardy. There is a quiz. Don't miss the quiz, by the way. If you have any question about Sphere, don't hesitate to contact me, Thierry Joubert at tourist.fr. I'm quite easy to find, I guess. And hope you enjoyed the talk. It's the last of the day, so it's been a long day for many of us, and you too, I guess. Thank you all. Bye bye.